Let me first introduce our speaker, who is Richard Chu, and he is Director of DApp Deployment. And he is here to show us how to speeding up Ethereum DApps by deploying to ThunderCore. So let's put our hands together. Welcome, Richard Chu. Thank you.
Okay. Thanks, Elena, for the intro. So, hi guys, I'm Richard. As noted, I'm heading up the app department at Thunder. So what we do at Thunder, there is the blockchain component of the core team that develops the core blockchain technology itself to be at this speed, at this scale. And then we also have the department that handles and deploy and try to develop the apps, right? So we also have to be our own customer. So we have to try to deploy the apps on our own platform and make sure it performs. And so a lot of the experiments that we've done so far has actually been trying out all the great open source smart contracts out there on ThunderCore, and to see how easy it is to actually do migration, and then how quickly that can happen and instantly get the benefit of speed and scale. So while doing so, we also wanted to create apps that demo the speed and scale of our blockchain. So something like a chat app, right? If you imagine that requires that kind of latency, that you need to be able to send a message in seconds or even sub-seconds, on Ethereum or on Bitcoin or most current public blockchain platform, it's not feasible, right? Sometimes on Ethereum mainnet, on our own experiences, a message may take a minute to complete, right? Imagine you try to send a message to, I try to send a message to Alina, it takes a minute for her to get it. That doesn't scale, it doesn't work, right? So, to demonstrate that, then you guys can also try it out yourself too, to go to our production chat demo.thundercore.com to experience yourself, right? And then, what we are demonstrating today is that you can actually try out. The same chat is a decentralized application, right, that connects from the front end directly through Web3 to Rinkyb, and also through Thunder, that you can experience right away that there's instant performance benefit and cost benefit of Rinkyb. It's already faster than the Ethereum mainnet, and even then it takes about 15 to 20 seconds to send a message and to complete the transaction. And then also transaction fee and cost is not negligible. Okay? And then as we see during different times of Ethereum, then during the peak times, then transaction cost could be right, dollars or even tens of dollars. On Thunder, we haven't faced and seen that kind of problem at all during our testnet testing. Right? We've seen near instant transaction confirmation and then almost trivial and negligible transaction costs. And then we'll also be demonstrating that the chat demo that we'll demonstrate will actually walk you guys through how to deploy the smart contract. And then we'll run on a computer, right, a local host front end to connect to the smart contract that we just deployed. And then we'll show you how quickly, right, you can actually just, the same smart contract will deploy Rinkyb on the spot for you guys. We'll deploy to Thunder on the spot for you guys. You guys can just see it for yourself how easy and how quickly that can happen. And there's no smart contract code change needed, right? And instantly you get the benefit. So at this point, I'm going to hand it over to our wonderful engineers. So here's Sam and Jack, and then they'll demonstrate both the front end and the user experience of that. It requires no change on the front end. All you have to do is switch RPC and you're on a different network, right? There's no code change needed. And also from contract deployment and the backend perspective, that it really is no smart contract code change at all. As long as you add the network ID and network information, provide RPC URL, that's it, you're good to go. So I'll hand it over to them.
We'll plug the HDMI.
Oh, okay.
Yeah, he wants to go outside.
Sure.
This guy was so short, this was too fast.
Hey guys, I'm Sam. I'm just going to demonstrate sending the same message, which is just a transaction, via Thunder and via Rinkeby. The important thing to note is that Thunder is much faster, as will become apparent, and also the front end requires no code changes. It's just the current provider changes from Thunder to Rinkeby. So first I'll send a message with Rinkeby. Yes, I'm already on the Rinkeby test network via MetaMask, so send a Rinkeby message.
That's the correct one.
All right, so I'll confirm the transaction, which we can see is not totally inexpensive, it's 5 cents. It's sending the transaction, so unfortunately we may have to wait a few seconds in this Rinkeby.
Yeah, and on average, Rinkeby is already much faster than mainnet, right? It's about 15 seconds compared to mainnet, sometimes over a minute in our own experiences. Seems like it's sent.
Yep, all right, it's just sent. You guys can also feel free to try this yourself. This is at chatdemo.thundercore.com.
To be the wallet.
You can also click to see the transaction on the chain too.
Yeah, sure. Let's check it out on Rinkeby. The Wi-Fi isn't the best.
There you go. But right away, you can see that I had to refresh. Yeah, 34 seconds ago, the transaction went through to the chain, so then chat transaction, right, as demonstrated here.
All right, now I'll send the same message with Thunder.
You have to click on the staging one first.
Oh, yeah.
Staging, and then click on it again. Test it. Yeah.
All right, refresh.
Yep.
Yeah, so all Sam is demonstrating is, right, the switch, all we have to do right now is just switch the RPC, right, from Rinkeby to a custom RPC URL that we have to enter. We have to work with MetaMask to actually get Thunder as one of the officially listed, so you can actually don't have to type in the RPC URL yourself, but that's what we've done so far.
And the great thing is as a front engineer, you don't actually have to change any code to support Thunder. Message. Confirm the transaction. We can actually send it with a much lower gas price. There we go.
Yeah, it's in.
Excellent.
Cool. Yeah, so
there's a Thunder message.
Yeah, that's links to our scanner.
yeah, and you can see how the transaction actually went through, and then we have our own current strip, like kind of a lightweight version of Etherscan that our Block Explorer to demonstrate that transaction actually went through to and is now on the chain.
Yeah.
And then one thing to note too from what Sam demonstrated in the UI is that the latest version of MetaMask actually kind of locks you in at minimum gas price of I think 1 GWA, right? But you can't even set it to be lower. But on our network, you don't need to spend 1 GWA as the gas price. It could be actually 1, not 1 GWA. So yeah, that's actually
one way.
Yeah, one way.
Yeah.
One way.
Kind of crazy.
Yeah.
Yeah, and if you need tokens, you know who to ask. This guy.
Sure, again, if you guys need test token in larger quantity, please.
Just email him, like, we need 50 tokens.
Yes.
And you can also request it via the chat. So straight.
Yeah, but we're gonna bump that from 1 test token to higher.
Yeah.
So I'll do that.
All right. Cool.
Yeah. So I'll show how to deploy locally. I'll walk you guys through it. So
This is Jack. So he's our full stack engineer. He's leading one of the projects.
one of the secret projects.
Is a secret or maybe so?
Anyway, so here's the chat room, and we have a client and smart contract folder. There is no server at all. The server is just a smart contract that got deployed. So if you look at our Truffle.js, we have Thunder and Ethereum and Rinkeby deployed, like configured here, and you can see from the Thunder one the gas price is set to 1. So we're gonna try that in a bit.
So this is pretty much the only code change needed, and it's not even related to smart contract. This is just configuration of Truffle.js.
Yeah, you just have to configure the RPC endpoint, and as long as it's a UVM compatible endpoint, it'll be good. So I'm gonna go over here. You can see that I have the client running. So Go to the client, complain about not having any deployment. Let's see. So we'll try to deploy on the Rinkeby first. Just enter. Yeah, so it's compiling the contract first. And for those of you who are familiar, that means for the contract that we want to deploy, it generates a JSON. And then at this point, it's not deployed yet. So as you can see, the network is empty object. And then this is the part where Richard, says
Yeah,
some
so,
of the things.
I mean-
Because Rinkeby takes a while.
Yeah, as we know, right, and then because our chat application contains different contracts, right, in this application, so then it has to go through each contract deployed one by one, so it definitely takes a little time, but you guys can actually experience and feel that too, is that when we're deploying the same set of contract to Thunder, it's fraction of the speed as well, right, because each contract deployment is a transaction, and then every transaction is just that much faster on Thunder.
Almost there.
Yeah, I mean,
Yeah, so by using Thunder to test your EVM, you can do it very cheaply and quickly. I think it's a good testing ground for CI/CD before you deploy to mainnet even. Yeah.
and it's mostly the tools that, especially if you guys have been working on Ethereum, it's the same set of tools that you guys are familiar with, Truffle, right? And then it's pretty standard, MetaMask, those things, all current DApp developer, Ethereum being the most prominent platform, we want to make it as easy as possible, right? That's why the full EVM compatibility really helps here, right? So then in our experiences, we've taken various open source smart contracts, including Kyber, right, and including CryptoKitties, right? These various smart contracts that just are out there. And then even on Etherscan too, there's the verified contract has the code that's available for everybody to see, right? We even try to just take some of those and then be able to try it out on our network. And then so far, it has worked wonders, right? It just takes, and then all I need to do is add in the network ID, and then you actually plug and play.
Okay, you can stop now.
Okay.
All right, let's deploy here. So network ID 4, that matches with the Rinkeby. Network ID 4. And this is where the contract is deployed. So we can now come back and refresh here. You can see that, hey, it took 0.3 like ETH to deploy there.
That's the other thing, for cost, yeah. So deploy that same chat contract. We wanted to try it out on mainnet too, and then we realized after deploying once, we spent about $100 to deploy a contract. So that was quite absurd. At that time, actually, probably close to 0.5 Ether at kind of peak time. So you imagine the cost of deploying one chat room contract is not negligible, and that's kind of underestimated.
Thunder also works with Remix. I'm a Remix user myself. It's not so popular like
Correct.
the other team, but yeah, it works there. So this takes a while to show up because MetaMask will also cache the reads because it assumes block comes in at a much slower rate. Anyway, so I'm gonna switch over to.
You should also see the transaction on Etherscan
Oh, yeah,
too,
yeah,
right?
yeah.
Because in this one, the contract we just deployed now is a new set of transactions.
5 seconds.
Yeah,
Yeah, here we go. Yeah, and here are the cost, the transaction fees. The big one is 0.22. Alright, so let me switch over to Thunder. Yeah, don't look at that balance.
It is a test account, so.
Yeah, that's a test account. So, alright. So as you can see, the JSON, like the network part is not deployed yet. We don't have this. We don't have the 19 key deployed here, so we're gonna do that. Thunder.
And you can see is the
Fingers
only thing we need to do different is really specify the network to be Thunder, and that's it, right? Because Truffle.js already has that pre-configured, and it recognizes the Thunder network. So only at Truffle migrate, that's the only place you need to specify.
It's almost done. Yeah, it's done. So we'll come back here and see that, hey, it's now deployed on these two networks. So I'll try to change my name. most of the time it's just waiting for MetaMask to load.
Yeah, the
Right,
MetaMask
it's done.
confirmation time
It's
is
done.
longer.
Right, Thunder. It's in.
Right, so even you guys kind of see it firsthand that same set of contracts, right, same front end, but instantly the performance benefit, the cost benefit is non-trivial. You can instantly feel it
Yeah.
and experience it, right? No code change needed. And even the most impressive thing is, as Jack mentioned in the Truffle.js, right, specifying the gas price. Right now, it could be, it's not even fractions, but it's right, one way. It could,
If you request one token from us and integrate Thunder into CI/CD for testing your contracts, you can use that forever for a while now.
Pretty much, yeah. So one,
Yeah, you
one
can
test
deploy.
token.
You can deploy contract every 5 minutes, every commit, every day. It's not gonna dent your balance at all.
Sorry, I have a question. So when you say it's EVM compatible, do you have like extended functionality on top of EVM, or is it just right now entirely EVM?
Right now, it's entirely EVM, right? So, but we're also looking at
They're working on some APIs.
yeah, there are additional APIs that are helpful, and especially for developers to debug, or is it to additional
More
API?
RPC and more wallet management.
Yes.
Right. So basically, right now, Thunder token is only compared to Ethereum, right? You just switch the consensus engine from the proof of work right now to the Thunder consensus, right? Thunder consensus. That's the only thing that's
Underlying,
changed,
yes,
right?
underlying thing, yes. To put it at a high level, yes.
Right.
Yeah.
So in the optimistic case where you have like a leadership, where like a clear leader consensus algorithm, where like traditional BFT kind of, and so when I connect, when I'm using MetaMask to connect like customer RPC to connect to if you're talking to a network that you're talking to a few well-known nodes on the core.
Yes, so yeah, it talks to our full nodes. So it actually sits behind a load balancer, and then so it basically talks to any one of our full nodes that could, right, you can connect to, similar to Pure in that sense.
Right. Another question that I don't really understand is like just now when you deploy, you say like you deploy to 2 nodes or 2 addresses. Is that?
No, you deploy to in Truffle. In Truffle, you're able to deploy to multiple networks,
Yeah.
and then when you use that in your front end, the nice thing is about it is you can switch the network in via MetaMask
Right.
and have the application still work,
Okay.
so that they're able to use the same application on multiple networks.
Okay.
Yeah, and I would definitely recommend using Thunder Test Network for your CI/CD to test your smart contracts for all the automations and other things. It's faster to verify, and the only thing that could trip you up a little bit is if your application depends on the block number. In Thunder, the block number increases much faster, so you cannot count on there being like 6,000 blocks a day or something. Yeah, you'll be something closer to 80,000 blocks a day.
Yeah. So it's pretty much happening. Block confirmation time is like around a second, or a little over a second per block, right? So then, yeah, and for real world applications, we've seen that random number generators, right, a lot of times depend on actual block number in the future, right? But as for Thunder's case, this actually probably wouldn't work that well, right? Because then, given how fast block increases, so.
But if you're using like a commit reveal approach for RNG, Thunder is pretty great because you can have both phases in like 2 seconds, so compared to 30 for Ethereum.
What about storage though? What about storage though? Because I think like even you changing the name, setting up your username is like a write operation into the contract, right? So if you're still using EVM, then I mean the storage is gonna add up pretty quickly, right?
Yeah. I think we have had applications for, like we have this 2D pixel map where people send in the data and we kind of generate this picture as a DApp, and the gas cost there, the gas unit cost is still low. So
Right.
yeah, but the amount of gas you spend, the number of gas may be high. But if you but it's gonna be multiples of one way, right? So.
Right, the thing is like, from user perspective, right, the gas is pretty low, the fee that pays pretty low, but like from
I mean, like
the miner, the operator or the validator or whatever, store so many data, and users are not paying for the time value of the write operation that they did. Yeah. So wouldn't that?
I mean, it's not a drop-in replacement for IPFS, so if that's what you're thinking.
No.
Yeah. After all, we're still running these on SSDs, so yeah. We would advise storing the heavy data outside of the chain.
So you're making the block bigger and faster. In simple words, as far as I understand. But what were the issues that you came with and that you solved about security? Like, what was the main thing that you needed to fight according to security? Okay, so for example, so what are you doing? You are making a transaction from one place to another. How much is the probability that somebody can steal this money during this transaction?
So then, I can speak, so this definitely more core blockchain related questions, and I encourage you to reach out to our core team to answer some of those. But from a high level security perspective is that, yes, we have a accelerator and also we have our consensus nodes to vote. So then these consensus nodes, right, as long as 3/4 of them, right, kind of vote on the transactions, and it will go through, and then that's in our kind of fast chain. So then we have and then we also have a fallback mechanism to, it's called our Aux network, that is pretty much just like the main Ethereum, that you can still have complete decentralized trust in that regard. So this is how we're balancing kind of performance and also security in terms of two places and two networks.
Yeah, you kind of have to attack like 75% of the node
Correct.
to like either order transactions differently or to deprioritize them.
Yeah, so that was still kind of like Jack said, right? So then using that mechanism, then we can still maintain that this is our public blockchain, right? Then you have to be able to do that at that scale in order to really try to make it not secure anymore.
So maybe just adds on from my understanding of the under consensus. Basically, it has two components where in the optimist phase, you're trusting on a traditional BFT, where it's super fast. Now, if the leader is like malicious, then you fall back to the work, which is so in the worst case, it's as fast as Ethereum right now. But in the optimum case, you are like opting out because you're thinking like it's not as malicious as we thought it was. Then it's very fast. So that's how we scale up. We combine the best of the both worlds. So if they detect that the leader is malicious, then you'll pull back to the work.
Yeah, until we sort this issue out, right?
Understood.
That's great.
Yeah, please.
Please, any other questions that you guys may have here or afterwards? Feel free to come talk to us, right? And then we want to demonstrate kind of the process of what we're going through to deploy, and we can work with you guys too, right? You guys have certain contracts that you guys wanted to try out, deploy today, right now. We're available here, at least for the next half an hour or so.
If you already have a truffle.js.
Exactly. If you already have truffle.js and then use it, then we'll definitely be here to.
Or if you already have your code running inside Remix.
Yes. Yeah. Or Remix. Yes. So,
yeah, we can help you deploy.
Yeah. So we want to make this more interactive after this particular presentation, such that we'll be on the ground floor and then actually help everybody try to deploy on Thunder. And especially you guys seen it just now, how quick and how fast it is to actually make it happen. So we want to encourage that.
Yeah, but I think a good step is to set up the but a good step to start trying is to go to the chat demo ThunderCore.com and make sure you have some Thunder test tokens in your wallet. Can't do much without MetaMask.